Hello everyone, this is another video on MCQs. We will be solving more MCQs for your CBSE board exam practice. Okay, we have already done 3 lectures in which we have solved MCQs. Okay, this is another sample paper. So let's start solving MCQs. This is another question. This is from military current. You can see the battery supplies 0.9 ampere current through a 2 ohm resistor and 0.3 ampere current through a 7 ohm resistor when connected one by one. The internal resistance of the battery is. Okay, let's try this question first. Okay, battery supplies 0.9 ampere current through a 2 ohm resistor. Yeah, uh, when connected one by one. Okay, so this is the battery. Okay, and battery has also an internal resistance, the small r, and suppose this is E. Okay, so 0.9 ampere current is going through it. Okay, this is first case. Second case, 0.3 ampere current through 7 ohm resistor, and the current is 0.3 ampere. Okay, again, this is the battery, this is the internal resistance of the battery. So these are the two equations, we just have to solve them. Okay, so this equation, if you see, it is E minus 0.9 IR, 0.9 into 2, that is minus 1.8. Okay, minus, this is current is coming like this, 0.9 into small r, 0.9 into small r is equal to 0. Kirchhoff's law. Again, this one also E minus 2.1. Okay, minus, this is R, right, 0.3 current into resistance is equal to 0. So we just have to solve these two equations. If we subtract these two equations, we'll get 0.3, and if you see 2.1 minus, this is minus 0.6 R is equal to 0. So 0.3 is equal to 0.6 R. So R is equal to 3 by 6, that is 0.5 ohm. Okay, so the answer will be 0.5 ohm. Alright, very easy question. Just try yourself, then only you go through my solution. Without trying, don't just copy paste. Okay, next question. Particle of mass m and charge q describes a circular path radius r in a magnetic field. If its mass and charge were 2 meter and 2m, sorry, 2m, mass is 2m and charge is q by 2 respectively, the radius of its path would be, like, the radius of its path would be. Please try this one. Particular mass m, charge q describes a circular path of radius r in a magnetic field. If its mass and charge were 2 meter and 2m and q by 2 respectively, the radius of its path would be. Okay. We first try, then only I'll solve. Okay. Mass m, charge q, circular path radius r. Now, if its mass were 2m and q by 2, the radius of its path will be. Okay, suppose radius of the path is r, small r. Okay. First of all, radius formula is what? mb by qb, right? We know mb by qb. So mb by qb is simply from this one. Here small r will be what? M is 2m. So 2m by q is how much? Q by 2 into b. Okay, so 2 goes off. So 4m by qb. Sorry, v, I missed a. So 4 MB by QB is what? 4R. So answer is 4R. Okay. Easy question again. Alright. Which of the following pairs is that of paramagnetic materials? Okay. So this one you check actually because I don't exactly remember this one. I don't think. I think it should be sodium and calcium. I'm not sure. Okay. Nickel, cobalt are your ferromagnetic. Lead are iron. These are ferromagnetic. Okay. These are ferro. This is ferro. I think sodium and calcium. I'm not sure. You just check it. Okay, I don't remember it properly. Just check this one. Okay. Next question. Galvanometer resistance 50 ohm is converted into a voltmeter of range 0 to 2 volt using a resistor of 1 kilo ohm. We have done this kind of question in the previous class. If it is to be converted into a voltmeter of range, this resistance required will be. Okay. So yeah, try. Convert into voltmeters. Voltmeter means voltmeter that will be resistance will be connected in series with the galvanometer. Okay, then that system is a voltmeter, but that thing will be connected in parallel with the whole circuit. Okay? So this is your 50 ohm. So galvanometer is 50 ohm. Voltmeter of range 0 to 2. We're using a resistor of 1 kilo ohm. So this is a 1 kilo ohm. Okay? Yeah. So the voltage for it we are getting is 0 to 2 volts. Suppose. So if it is converted to voltmeter of 10 volt, resistance required will be very simple question. Again, this is current, and you can see. So it will be what I into R. Okay. So V is equal to what 1 kilo ohm. So suppose 1000 into I minus 50. This is 50 into I. Okay, is equal to 2 volt. So current will be 950 I is equal to 2 volt. So I you can get from here 2 by 950 ampere. Okay. So whatever we are getting here, we can put it here. Very simple. The simple now the system is just we will take this R. Okay. So it will be V 10 volt is equal to I, that is 2 by 2 950 into R. Okay. Minus, okay, I made a mistake here. Sorry, this is okay. This is plus. Sorry. Because I have taken all of this to the side. See why this is plus. Okay, let me explain it again. I made a mistake. So the equation should have been V minus IR minus IG is equal to 0, something like that, right? So V is equal to IR plus IG, correct? So this will be plus, okay? So I R plus G. So I all into 1050. Yeah. So I is equal to 2 by 1050, and that you will put it here in this equation 1050 into R minus this is suppose R dash, okay? R dash minus G is 50 ohm constant 2 by 1050 into 50. So from here you can get R dash. Okay, very simple question. Let's try and solve it. Okay, did you solve it? Alright, let's move to the next question. Two coils are placed near each other. When the current in one coil is changed at the rate of 5 ampere per second, any EMF of 2 millivolt is induced in the other. Mutual inductance of the two coils is. Again, very easy question. Let's try. EMF is equal to M di by dt, right? Where M is your minus M actually. I take the magnitude M di by dt. Where M is the mutual inductance. Di by dt is given 5 ampere per second. EMF is given 2 millivolt. So the mutual inductance is also. What do you want? This is easier as it can get. Minus 3, sorry. Is equal to M into di by dt is 5. Okay. So M is equal to 2 by 5, that is 0.4 when 10 to the minus 3. So 4 into 10 to the minus 4. Okay, what is the unit of mutual inductance? It is inductance means Henry. Okay. So answer. So 4 10 to the minus 4, that is 0.4 millihenry is the correct answer. Radioactive waves used to purify water. Surely ultraviolet UV. You must have seen the ad UV pure water, something like that. Okay. Next, please try this one first. I'm not gonna solve it. Focal lengths, objective eyepiece are given, tube length is given, magnification obtained by microscope. So you just try first. Most suitable viewing by relaxed eye. Okay. See, most suitable viewing means the image is formed at infinity. Okay, that is the meaning of it. And this is not a simple microscope because the simple microscope has only one thing, that is your only one lens. But your compound microscope has two lenses. One is eyepiece, one is objective. So objective and eyepiece they will be placed in such a way that the image will be formed at infinity. Okay, final image is formed at infinity, then only the eye will be able to see it with a clear viewing, which is asked in the question. Okay, so the final image will form at infinity. For that, the magnification formula you need to remember, that is minus. What is the formula for it? What is the formula? Minus L by F naught. Write down the formula, minus L is your length of the tube, minus L by F naught into D by Fu, where D is your what? Distance of distinct vision, which is your 25 centimeter, and this is your L is given 10 centimeter. Okay, F naught is given 1 centimeter, Fe is given 2 centimeter. So just have to put everything, and that will be 10 by 1 into 25 by 2. So that will be minus 125 centimeter. Okay, yeah, but sorry, yeah, magnification. Sorry, minus 125. So it's 125 will be the answer. Okay, I think something should be minus from here. I think D will be minus because it's to the left of the lens, maybe. I think this one should be minus or something. Okay, so that will be plus. The answer will come in plus eventually 125. Variation of the stopping potential with frequency in view of the incident radiation for metals A, B, C, D. It's shown in the figure. With the same frequency of incident radiation producing photoelectrons in all metals, the kinetic energy of photoelectrons will be maximum for metal what? Which metal? Variation of stopping potential with the frequency of the incident radiation is given. Same frequency of radiation, kinetic energy of photoelectrons will be maximum. Frequency is incident radiation same. Variation stopping potential is given. That means kinetic energy max is equal to V naught, EV naught, right? So kinetic energy directly is directly proportional to V naught, and the frequency is as said in the question, same frequency of radiation. So frequency is same. So the one having the okay, wait. So the same frequency of incident radiation production variation is covered with the frequency variation is given. So the same frequency. See, frequency is same, but here, okay, I think this one should be new. This one should be V naught because see, frequency is same for ABCD. This which is given in the question. But here, if it was frequency was an x-axis, then it is different for ABCD. So stopping potential is different for ABCD. Frequency is same for it. See, so frequency should be y-axis. Okay. So, kinetic energy for photoelectric maximum. Very simple. The one having the maximum V naught will have the maximum kinetic energy. Which is the maximum V naught? D. Right? D is the maximum V naught. Not this. This. Or you can say also this one. So D is the D will be the answer. Okay. The energy of an electron in the ground state of hydrogen atom is given. Kinetic potential energy of the first excited state. Okay. First excited state. First of all, in the ground state, let's calculate. Energy is minus 13.6 eV. What is the kinetic energy and what is the potential energy? Relation between kinetic energy, potential energy, and total energy you need to know. Otherwise, you can't solve it. Please try this question. Try to remember what is the relation between kinetic energy, potential energy. Yeah. Okay, what is the expression for kinetic energy? Just tell me. Expression for kinetic energy is kjd square by 2r, right? Expression for potential energy is minus kjd square by r. Right? Yeah. So yeah, so from there you will see the relation between kinetic and potential is what? Minus 2 into kinetic energy is giving you potential energy, isn't it? Minus 2 if I multiply. So see, check kinetic potential minus 2 of kinetic energy is giving potential. So this is one option. Any other option you have? Yeah, this one, another option. But the thing is, first excited state, that means n is equal to 2. Okay, minus 13.6 by n square. So yeah, that matters. So I think option B will be the correct answer. Okay. Yeah. Next question. Young's double slit experimental setup is kept in a medium refractory index this. Okay. Which maximum in this case will coincide with the sixth maximum obtained in the medium with respect. We just try this question. Okay then. Okay, let's move to the next question. Try this question now. Potential with two nucleons and nucleus minimum at a distance of about which one? Which one is the answer? From now on, you solve all the questions. Okay, this one also to be 1.6 for me. Pure silicon crystal having is due to 1 ppm antimony. Okay, concentration of holes in the deep is found to be this. So concentration of intrinsic. So Ni is asked. Ni is what? NH into Ne, right? And antimony is yeah. So this is your NH is given 4.5 into 10 to the power 9. Ne is given this one 5 into 10 to the power 28, but it is mixed with 1 ppm, so per parts per million, that is 10 to the power minus 6. So this becomes 5 into 10 to the power 22. Okay, so 5 into 10 to the power 22. This one is 4.5 into 10 to the power 9. So just multiply them, you will get the answer. Okay. Okay. Next question. And all these are assertion reasons. So we have done 12 MCQs today. I hope you understood. Right. Any doubt you can ask me in the comment section. Okay. Thank you very much.